So we should start with the exercise 5.1 children. The first question is, in quadrilateral ACBD, A side AC is equal to AD and AB bisects angle A. Show the triangle ABC is congruent to triangle ABD. What can you say about BC and BD is the question. So given that ACBD is a quadrilateral. So you know what is a quadrilateral. So here we need to prove that. Now for this quadrilateral ACBD children, a diagonal is drawn. What is a diagonal? It is a line segment which joins the non-adjacent sides. You know the meaning of adjacent sides. Now for angle A, angle C is adjacent. For angle A similarly, angle D is also an adjacent side. But for angle D, angle B is adjacent angle. But for angle A, it is not, angle B is not beside angle A. After C, you have B. Similarly, after D, you have B. So, A and B become non-adjacent. So, if you join the non-adjacent vertices, that line segment is called a diagonal. You know all these basics. Now, they have drawn a diagonal to the quadrilateral ACBD, which is dividing the quadrilateral ACBD to two triangles. Which are those triangles? It is very clear. Triangle ACB one triangle and triangle ADB is the second triangle. So, we need to prove those two triangles form. See, this is triangle 1, this is triangle 2. They are asking us to prove those two triangles are congruent to each other. Now, first thing children, before I will give you the solution, you will practice it, you will write in test or exam, you will score good marks, finish. No, that should not happen. What I want you to do is children, try to apply the concept, what you have studied, basics, theorems, whatever you study in geometry, no children, you should try to apply that. Which can I apply? Which rule can I apply? That you should think, that capacity you should get by practicing. So now, look, first what you need to do in such problems is carefully observe the figure. Why? Because children, I said, they will mention which angles are equal, which sides are equal. That if you understand, easily you can solve problems. So, first you should know how they represent symbolically which angles are equal and which sides are equal. Look now, on side AC, one line is there, side AD, one line is there, and side AC is equal to side AD, and it is understood. Similarly, this and this angles they have given as equal. Why do you think it is equal, children? Why? Because they have only given us the reason. AB is bisecting angle A. The diagonal what they have drawn is bisecting angle A. Something which bisects, you have learnt in constructions also. Bisector means it will divide the angle into two equal halves. So, that AB, the side AB or the length AB is bisecting the angle A, means angle A, if it is 30 degree, it will be divided into 15 plus 15. If it is 50 degree, 25 plus 25, like that it will bisect. Means two equal halves. So, these two angles are equal, it is understood. So, you should observe the figure carefully. Now, they have only given one angle and one side as equal. That only we will write as 2 points. One side ಸಿಕ್ತು, one angle ಸಿಕ್ತು. ಇನ್ನೊಂದು ಸೈಡು ಅಥವಾ ಇನ್ನೊಂದು angle are equal ಅಂತ if at all we prove, children. Of course, by SAS or ASA congruency, we can easily tell these two triangles are congruent and hence the problem is done. That's it. So, what I have done is, first I will tell the given data. These steps you practice. In quadrilateral ACBD or ABCD, ACBD, non-congruent ಆಗೋಗುತ್ತೆ. So, in quadrilateral ACBD, it is given that side AC is equal to side AD. Side AC is equal to side AD. What we need to prove? Triangle ABC is congruent to second triangle ABD. In triangle, here starts our proof. Very simple, 3 steps, finish. In triangle ABC and triangle ABD, children, side AC is equal to side AD. How? You should give the reasons in brackets. All this you know. So, side AC is equal to side AD. How? It is given data. So, easily we will write AC equals AD. I said, one side, one angle, so angle we will mention now. Angle CAB is equal to angle DAB. CAB is equal to angle DAB. Why? Because they have only given us that AB bisects angle A. AB is bisecting angle A. They have given one point now in the problem that we are utilizing here in order to prove one angle is equal. Now if you consider these two triangles, children, for both the triangles, this diagonal AB, which is dividing the quadrilateral into two triangles, is common to both the triangles, isn't it? So for triangle ABC nallu side AB there, triangle ABD also have side AB. So AB equals AB. Why? Because it is common side. That is one more criteria we are taking in order to prove they are congruent. So side, angle, one more side. Therefore, triangle ABC is congruent to triangle ABD by SAS congruency rule. Done. So we proved these two triangles are congruent. But here they have asked, what can you say about BC and BD? Which are, so this side is BC, this is BD. How about BC and BD? Are they equal or not is their question. The answer is BC is equal to BD. Side BC is equal to side BD. Why? You have learned about the CPCT. If at all we prove that it is congruent parts of congruent triangles. CPCT andre congruent parts of congruent triangles. Congruent parts means what? Now we have proved these two triangles are congruent by using this side and the common side. So this remaining sides of the two triangles become the congruent parts. Similarly, we proved angle A and angle A are equal means other two angles also will become the congruent part of the congruent triangles by CPCT. So CPCT, children, we can easily say BC equals BD. That's it. That ends the first problem. Second question is, compulsorily copy the figures. It is very important because that will only give you the solution, which angle, which side and that. Again, ABCD is a quadrilateral in which AD equals BC and angle DAB equals angle CBAC. Angle and side we got. Prove that. Three cases they have given. First case only we need to prove triangle ABD is congruent to triangle BAC, children. So again you have the quadrilateral ABCD. Here two diagonals are drawn. Here only one diagonal was drawn. Here two diagonals are drawn which is dividing the quadrilateral into triangles. Now what we need to prove? Triangle ABD. This triangle 1 is equal to triangle BAC. This triangle, if you want, I can share it for you. This either bitbidi. This you forget. Triangle ABD, this triangle is congruent to this triangle and we need to prove in case 1. So, in case 1 nalli, in triangle ABD and triangle ABC, side AD is equal to BC. Why? It is given data. Similarly, angle DAB is equal to angle CBA. These two angles are give equal. Why? Because again it is given data. But again if you look, children, now triangle ABD anta helta, side AB is included. Similarly, triangle BAC anta helta, no? Side AB is included, like as we did here in the previous problem. So again side AB equals side AB, but it is common side for both the triangles. Therefore we can say those two triangles are congruent by using SAS congruency rule. Once we prove these two triangles are congruent, their congruent parts also become congruent. How? By CPCT, just now I explained you. So that gives answer for second and third sub questions of this question number 2. We need to prove BD equals AC. So BD is and AC. BD is equal to AC means the diagonals are equal. We need to prove. By CPCT we can easily say the diagonals are equal. Similarly, angle ABD, this angle is equal to angle BAC. These two angles are equal. Angle ABD and angle BAC. These two angles are equal and prove ಮಾಡಬೇಕು. Of course, they becomes the congruent parts of two congruent triangles. Hence, by CPCT again, they are equal. That's all. So that is about the second question. Next, we shall solve the third one. Third one, it is very easy, children. I want to take it as homework. AD and BC are equal perpendiculars to the line segment AB. Show that CD bisects AB. Very simple. What you need to do is, they have given the figure, no? I will roughly draw here. This is the given figure and intersection point O is the children. Here they have given labeling also. I will write for you. AD BC anta ide. Look, they have said AD is equal to BC anta helidare. Similarly, angle B and angle A are equal. Why? Because they are right angle, that is 90 degree. And their intersection point is O. Here this intersection point O is dividing the figure into two separate triangles. So one angle they have given, one side is given. O becomes the common angle here. As we used to say, AB is common side. Here also AB is common side, children. Here angle O is common for both the triangles. So by angle side angle congruency, you prove that these two triangles are congruent, means you can say CD is bisects. So show that CD bisects AB. CD is bisecting AB, you can say by CPCT. Finish. Very simple. I want you to take it as homework, children. I will be solving the fourth problem now. To solve the fourth problem, children. It is given in the figure that L and M, you can see the lines L and M, P and Q. The line L is parallel to M and line P is parallel to line Q. They are nothing but parallel lines. So, L and M are two parallel lines intersected by another pair of parallel lines P and Q. Show that triangle ABC is congruent to triangle CDA. So, L and M, P and Q are parallel lines, as I said. Here in the figure, if you observe, these two are the triangles, children. I have shaded it for you to make you understand. Triangle ABC is one triangle and ADC is second triangle. We need to prove those two triangles are congruent. It is very simple again. So what you should write is, in the figure L is parallel to M and P is parallel to Q. Now in triangle ABC and triangle ADC or ACD, anywhere you can take, angle BAC is equal to angle DCA. I want to draw and show it to you. As I always say, you children, if you don't get to know how these angles are equal, you just draw them. Draw those lines now. Angle BAC, B is here. Angle BAC, this is B, this is A, this is C, is equal to angle DCA. I have written. Here is D, here is C, and here is A. Alva? Angle D, this is angle DCA. Now these two angles are angle A and angle C. Wait. Angle A and angle C. Oh, BAC. Now I draw ABC. Angle BAC and angle DCA. Angle A and this is angle C. Now children, these two angles are in Z-shaped. Z-shaped angles are called alternate angles. F-shaped angles are called corresponding. How will you get F-shaped? Like this. F-shaped angles are corresponding angles. You have learned this in 8th class. So here now angle A and angle C are alternate angles. Why? Because they form the Z-shaped. They are alternate angles. So angle BAC is equal to angle DAC. You can write from the given figure. Similarly, angle C and angle A. Oh, first we took angle A and angle C. Now angle ACB. I will write here for you. Angle ACB, this angle is equal to angle DAC. This is D, this is C again. So again these two angles are alternate angles again, but they are alternate interior angles, children. So two angles are equal, we have proved already. Why? Because they are alternate angles. If you write alternate angles also, it's enough. Now for both the triangles again, AC is the common side. So we do that always. AC is equal to AC by common side. Therefore triangle ABC is congruent to triangle ADC. That's all. Next we shall move on to fifth question. Line L is the bisector of angle A. By looking at the figure only you can find out. For this angle QAP children, this L, the line L, what is drawn? That is bisecting angle A into two halves. I said you what is bisector mean in the previous problem. So line L is bisecting angle A there. B is any point on line L. So B is some point. BQ and BP are perpendiculars from B to the arms of angle A. Now if you have angle A here, which are its arms andre AP and AQ are the arms of angle A. Now one angle higirutte. Here at the intersection of my hands the angle is formed andre AP is one arm, AQ is one arm. So AP is one arm and AQ is one arm. That is what they have given. And from those arms, from this point, the perpendiculars are dropped onto the arms of the angle A andre point B in the BP is perpendicular and BQ is perpendicular to BAQ, BP is perpendicular to AP. So angle Q and angle P becomes 90 degree. Why? They have only said it is perpendiculars drawn. Show that triangle APB is congruent to triangle AQB andre. E triangle ideyala, these two triangles, right angle triangles what are formed are congruent we need to show. To do so, in the figure line L bisects angle A and triangle ABP and triangle AQB. I forgot. In triangle APB and triangle AQB, angle APB is equal to angle AQB. Why children? P and Q are right angles. They are equal to 90 degree. So they are equal and it is a given data as well. Similarly, angle PAB, angle A is common to both the triangles, and as well as we know that this line L is bisecting angle A means this angle BAQ is also equal to angle PAB. That is what we have written. Why? L bisects angle A. And again for both the triangles, this is like icing on the cream. It's a common side. Okay, icing on the cake is a common side anta for triangle if we take children, that will become one side. Hence, two angles and one side are equal andre. Oh, two angles and one side, no children, we proved. Two angles are one side andre. By ASA congruency, triangle APB is congruent to triangle BPQ anta we proved. Now the question is, second part they have asked to show that BP equals BQ. BP equals BQ andrunu onde, or if we say that what is it? B is equidistant from the arm A of the angular bisector A anta kottidare. So both are same. So of course we have proved these two triangles are congruent andre. By CPCT we can say BP equals BQ. BP equals BQ andru onde, or point B is equidistant from the arms of angle A andru onde. Hence it is proved children. Very simple problems these are. You can only try to apply which congruency you need to do. So 6th and 7, 8, 3 more problems we have. We should solve them.